Hello, class. This week and for the next next 2 weeks, we're going to really focus on wrapping up the class with our plant physiology for precision agriculture lab. Now, we held off on this lab last week so y'all could finish up your plant hormone lab. I expect those will look pretty good. It's kind of a fun project. We didn't have all the necessary materials, as you probably found. It would have been good to have a source of carbohydrates in there with that auxin. But I think we had a pretty good coverage of that. And it looks like some of you all have done a good job of getting those in and doing a really nice job on that. So anyway, this week, we're focusing on plant physiology for precision ag. We're going to drop the carbon and nitrogen allocation paper class, and we'll spend this week and next week hopefully getting that plant physiology for precision ag experiment wrapped up. Now, as a heads up, you'll need at the very least 2 weeks to get this done. And this project will be more or less the last project of this class. We're going to drop the presentation part so that you can focus on the precision ag or plant physiology for precision ag, the corn orientation experiment, and you can have a very nice, well-written paper about that. And you'll see that as the activity sheet. The materials needed for this: corn seed, a tray, and some soil media. I was using some Jiffy pots, Jiffy peat pellets. You'll see those in the video following this, but that's our focus for today. Now I'm going to stop share and reshare the paper that this is based off of. So this is actually the work that you're going to do based around you validating the results of this paper here titled Maize Leaf Angle and Emergence as Affected by Seed Orientation at Planting. Now, it's a pretty simple paper, but a really good paper, especially for what we're doing today. What we're going to do is validate 3 treatments of their experiment, treatments 2, 3, and 10. You'll see those mentioned in a little bit, to see what sort of effects planting seed in a very precise way, corn seeds specifically, has on the amount of time it takes for the seed to germinate and the way that those leaves emerge and come out. So I recommend you take some time to read this, because you'll want to read through this to have a good idea how to answer the assignment that goes with this. And this will be a pretty high point assignment. This is a 50-point assignment, 10 points per question. But as we read through, we'll see it has an abstract. That abstract's shown as a summary. And the summary is, again, the abstract, it summarizes what they did, the work that they've done. It says maize seed orientation at planting can influence emerging leaf angle. So a pretty good, strong statement to start off with. If leaf angle were consistent among plants in a field, say a row of corn, without leaf overlap, large numbers of these bilaterally symmetrical plants could be arranged to optimize light interception and possibly increase grain yields or maintain yields with lower populations, right? A lot of what we've seen with corn over the past 50 years or so has been increasing seeding rates, reducing corn row spacings, right? Having greater numbers of seed put down per unit area, from say 50,000 to 100,000 seeds per acre, right? And what the case that this author is making is that based on what we know about plant physiology, we can set up these seeds in such a way that it can capture more light, perhaps allowing us to increase yields. It can, say, use fertilizer more efficiently by capturing sprayed fertilizer in the right way. Perhaps it can better compete with weeds or better use pesticides, right? So I suggest reading through this summary. We can talk real quickly about the introduction. They go through in the first 2 or 3 paragraphs about why this sort of work is important for precision ag. This will help you answer your activity sheet. But they talk about, like we said already, late interception, those effects on herbicides and weed management, more uniformly grown plants. That's huge for precision ag. So in this experiment, we're going through and we're planting those seeds one by one. But if you can set up a piece of equipment, which we can, to plant these seeds in a very particular way, then that precision ag equipment that comes to the field following can be more efficient. So can the applicator, right? If it's not using precision ag technologies. When they talk about some previous experiments that have looked at the same question, but this is among the more comprehensive experiments, at least within corn, that I've seen, and a really good one for us to, like I said, do some validation on, which is what you're going to do today. They talk about their materials and methods. You can read all the materials and methods, but what I really want you to focus on is table 2. Table 2 is what your in-class experiment is based on. We see that they have a treatment structure that has 13 treatments. They have pictures of what those treatments are and a description of what those treatments are. Again, you're going to focus on treatments number 2, where you have seeds that are placed in a row upright on the side, that caryopsis pointed east and parallel to the row. We'll have treatment 3, which is kind of just stabbing the seed through, where that seed is upright, the caryopsis pointed down, and it's parallel to the row. You're going to have treatment 10, this one down here, where the seed is laying flat, that embryo in the center there is pointed up, and it's perpendicular to the row. So your job is to go through and set that particular experiment up. And then I want you to go through and track, say, how long it takes for those seeds to emerge. Just keep track of that. I want you to take note of, at the very end of it, what sort of orientation those leaves are at. You don't have to be as precise as this, so please don't panic about that, but just general observations. They use this really fancy trigonomic circle. We're just going to talk about our observations. This paper is showing a little bit about what sort of variation those authors saw when they planted the seeds, right? So they've got plants laid out here, and that's kind of showing that variation that they saw from planting. You can scroll through, you can read a little bit about the results. They have a nice results and discussion section where they say, oh, this is what the leaf angle looked like and the emergence. And I want you to reference back to this to see how it compares to yours. And what you're doing is you're looking again at experiment 2 of this paper. They have a couple experiments in here. We're really focusing in on treatments 2, 3, and 10 of experiment number 2. They show things like row direction. This is what your plants should look like for experiment number 10, or I'm sorry, treatment number 10 in your experiment, right? Where they plant those seeds all in the same way, and voila. They're also showing, here's what those plants looked like for treatment 10. That's one of your treatments going through. Really neat project. And they also have at the end a nice conclusion section. Check that out, pretty good information there. But from that, I'm going to show you what that experiment actually looks like. So let's hop into that. All right, now we're gonna actually set up this experiment for real. Let's see if I can, there we go. I've got 3 rows of pots. I'm gonna actually just turn these for you. Let's see, I've got 1 row for treatment number 2. I don't know if that's showing up on the camera or not. 1 row for treatment number 3, and a row for treatment number 10. These are according to, remember, experiment number 2. So I've got these nice little peat pots. They work pretty well. It's just a little wafer. Once you add water, you'll see they expand. And I'm going to put my treatment 10, 5 seeds each. Treatment 2, well, you can kind of see it on my screen in your mouse when I wave my hand over. It's kind of crazy. Treatment 3 and treatment 2. So I'm going to add water now. Let's see these little wafers expand. All right. I don't make too much of a mess on my desk. So the wafers are slowly taking up that water. You can use just regular soil media if that's what you got at home. You can invest in these wafers. I'm a pretty big fan of these wafers, or whatever works for you. At the end of the day, you'll want to figure out the best way to get this experiment to complete on its own. So I'm going to pause the recording, and we will pick it up once these have expanded. At this point, my plant or my peat pots have fully expanded. They went from those wafers to these cool little I don't know, containers for corn seeds. You might have to rip some open for a nice successful planting, but should be fine. Now, at this point, we're going to plant our seeds. So I'm going to plant treatment 2 as described. So let me pull up the screen to read that real quick. Treatment 2, let me scroll up. Treatment 2 is described as sitting upright on the side, caryopsis pointed east, west, east, okay, parallel to the row. So I'm going to plant them all like that. Let me hold this up. See it a little bit better. I'm going to make this image quality a little nicer. So that's it. We're just going to point that embryo facing the same way on its side, and all of them will face that same uniform direction. All right, I'm going to continue on. So everything in my treatment 2 row ends up looking about the same. Oops. Making sure that embryo is facing the same way. So it's embryo facing, I guess, the camera at this point. Placing that in. I'm going to do that for all 5 of these within this row. So now that they're all there, I'm just going to press them in. My best to make sure that they all fit that same sort of description that we see in table 2 of the paper posted for treatment 2. And these peat pots hold water very, very well, which is pretty beneficial for what we're doing. Make sure those seeds get planted so they're set up for good emergence, good germination. I like to cover them a little bit with the peat that's in there. All right, now we're going to do the same thing for treatment 3. I'm going to have, let's see, upright, so setting up, oops, like, best way to show this, like so. Right, the last one was on its side, pointed east. Right, that was treatment 2. Treatment 3 is just flipping it 90 degrees. Like, oops. Like so. If you can see the screen, hopefully you can see it better than it shows up on my screen. We're just going to do that for everything. So I'm going to Whoops, that's not right. Put them straight in according to treatment 3. Just kind of the pokey end down. So they're all set up pretty well now, I'd say anyway. Great. All right. I'm just going to do the same thing. I'm just going to plant them by pushing them straight in there. Cover them up a little bit with that peat in the peat pot, or the little peat container. And this is treatment number 3 that we're setting up right now. Make sure that these stay watered, right? These are biological organisms. At this point, I think we're all good plant people by now. Treatment 2 and 3, I'll stick those tags in the first one on the row. Now finally, treatment number 10, that's this row. We're going to lay it flat, embryo up, perpendicular to the row. So we're just going to lay them all flat. They should feel a lot like that third treatment. Now, imagine if instead of us doing this by hand, there is a planter that could do this. That'd be pretty valuable for a grower. So it turns out that technology is already here, right? Now, we'll see, maybe there's a treatment or a seed orientation that emerges around the same time. So I want you to keep track of when these plants emerge. I want you to keep track of what sort of uniformity they have in terms of leaf angle, like we saw in the picture in that paper earlier. And then make some good, draw some good conclusions from that. Okay, these are all planted. I've got them in nice rows like the paper describes. Those leaf angles are set up. I'm excited to see what you all get. And we can share our results together. So go ahead, complete this part of the experiment. I'm going to share my screen real quick here and show you the activity sheet. The activity sheet, I just want you to demonstrate that you've done this experiment, showing me some pictures, and then talk about what differences you observed. Now, this answer shouldn't be one sentence, right? You should probably have a very solid 5-sentence paragraph off of this, right? Just pretty broad. What treatment or what differences do you observe between treatments 2, 3, and 10? Did one of these treatments produce more uniform plants? Did they germinate more uniformly? If so, which treatment? And then speculate why, and answer based on your knowledge of crop physiology. Again, this should be about a 1-paragraph response, 5 sentences. And then this next question 5, next question should be about 3 sentences long. How can the results of this experiment positively impact commercial agriculture? And give 3 examples, right? 1 sentence per example. All right, with that, I look forward to seeing what you all do.